Greetings and welcome to my channel, and apologies for not having more installments in recent months. Life has taken interesting turns. All's well, just interesting. You'll notice I'm wearing a short-sleeved shirt. I've returned to my natural plumage. Texas has thawed out. You'll also notice I'm not wearing glasses. That's due to the genius and skill of Dr. Bo Swan at Brazos Eye Surgery in Waco. I was nigh on blind. Now I have 20/16 vision. This video, and two more that will follow, are in response to a wonderful presentation by Professor Phil Bell. He recently showed a fascinating proof of Pythagoras as discovered by U.S. President Garfield. That was the same year Alexander Graham Bell created the telephone. He also presented a great proof of exterior angles in a triangle. Professor Phil, if you see this, I'm humbled. I'd also say I'm honored, but the honor goes to the physical world's incredible faithfulness to math, algebra, and geometry. This video is not sponsored, by the way, but it's at least boosted by the genius of the band Little Feat. My wife's from the Appalachians. She's made of the same stuff the hollows and runs of rural Virginia are made of. She's definitely not Cajun, but there are some Little Feat lyrics that always make me wish I could do better by her. With innocent heart, true talent so rare, she bloom on the bayou, this flower so fair. She's a mountain gal, no doubt. She's also descended from two Nobel Physics laureates, father and son William Henry and Lawrence Bragg. She can shoot dinner and cook it, hold her own in any debate, and I can't get away with nothing. No way can I sneak anything past her. Anyway, Little Feat is playing as I write this. It always affects me. I've got a point to make. It's going to take a few videos. This one, and let's see, we'll need to show Trig isn't complicated, and then our grand finale, at least as far as this three-part effort goes, in which common sense demonstrates Pythagorean coolness. I already see someone fixing popcorn. Me, offering insight into trigonometry. Right. And you thought pi was irrational. Well, there is something I can pass along. My first irrationality is that I think I can make trig functions simple enough even a flat earther could understand. Second, I have long experience as an underachiever. Trig, as presented to me long ago in high school, was a complete mystery. I wrestled with it and finally worked out a perspective that works for me and might work for you as well. I'd like to pass that along to any who share my former glazed-eye wonderment of trigonometry. But demystifying a little trig isn't my point. My point is something I've poked at in past videos, that math isn't just real. Real wouldn't be real without math. It's a beautiful thing, the uncanny precision of the cosmos, and it isn't just that regular math is real. Symbolic math, that stuff we call algebra, is just as real. First, let's prove Pythagoras. Now, I know what you're thinking. That equation doesn't have c squared. That can't be the Pythagorean theorem. There's no assertion a and b are the legs of a triangle. There's no claim of a right angle anywhere in sight. All of your objections are quite true. This is, nonetheless, Pythagoras in action. Let's follow this by proving Pythagoras. May I present a right triangle? It's nothing special. Any triangle with a 90-degree angle will do, but I like this one. You may use it too, I'll share. Let's add 3 additional copies. I'm pretty sure we have the production budget for 3 more. There are things to note here. In each triangle, the length of the short leg is A, the long leg is B, and the hypotenuse is C. I'm going to skip over trivial intermediate proofs. If anyone doubts assertions I make in this series, trust me. I may be a dummy in math. I may have no more than a third grader's understanding of trig. But I stand, I think, on pretty firm ground in this particular case. Pose questions, I'll do my best to answer them. Here's an example of an assertion in the interest of saving time. The outer figure here is a square. The angles formed by the 4 sides are all 90 degrees, and the segments on the sides form straight lines. The proof is easy, but it isn't the main point. So let's go with the obvious. The outer figure is a square. By all means, track down the proof for yourself. I need to move on because I spent too much time gushing about my wife. The inner region is also a square with 4 equal sides and 4 90-degree angles in the corners. The sides of that inner square region are of length c. Therefore, the white region is an area of size c squared. Now let's rotate 2 of those triangles. The 4 triangles, now forming rectangles, have not changed size. The outer square has not changed size, so that squared off z-shaped white area is still of size c squared, even though it's not a square anymore. The short sides of the rectangles, by the way, are of length A, the long sides are of length B. Now let's rotate one of those rectangles by 90 degrees. The outer square remains the same size. The two rectangles covering the area of our four right triangles stay the same size, so therefore the white area is still c squared. And look, c squared is now split into two regions, both of which are perfect squares. The smaller square has sides of length A. The larger square has sides of length B. Together they equal c squared. A squared plus b squared equals c squared. Hello, Pythagoras. But wait, as Professor Phil would say, there's more. The outer square has sides of length a plus b. Its area is a plus b quantity squared. The white squares are a squared and b squared. The two blue rectangles have sides of a and b, so they are each of area a times b. A plus b quantity squared equals a squared plus b squared plus 2ab. Does that work algebraically? So there's Pythagoras hiding in a plus b quantity squared. How about that? We've got symbolic algebra that evolved from Pythagoras that matches lines we could paint on a parking lot. You may consider this the general case, that math, algebra, geometry, and the real world are all different faces of the same dice. Even imaginary numbers, the bizarre case of two-dimensional number lines with real and imaginary components, carry a relationship to the same sine and cosine you see at work everywhere in the real world. I don't know what this proof of Pythagoras is called, but I think of it as Finland's flag because that country's flag is sort of inadvertently Pythagorean. This will come back in the third episode of this series. First, though, get ready for world-dominating power in our next presentation. If trig functions confuse you as much as they confused me, get ready to seize the world in your calculator. The CIA has their silly remote viewing nonsense. You will gain remote precision, the ability to predict force, derive dimensions without direct measuring, all kinds of fun. Best of all, we know it's all real. It's math. What could be more real than that? And now comes some fun. None of the foregoing was peer-reviewed. I pass that torch to you, dear viewer, and I do so for two reasons. First, and obviously, statements of fact must reveal themselves to all qualified observers. Statistically, if you're watching this, you're more qualified than I to have an opinion about math. Please let me know my errors in your comments. The other reason I defer peer review to you is because this is healthy stuff. I particularly like to work on classical ruler and compass construction when the alarm goes off in the morning. Hit snooze, close your eyes, and imagine a whiteboard. Spend a few minutes chasing triangles and circles through the air, and the rest of your day will be nicer to you, guaranteed. Thank you for visiting. If you like this kind of presentation, please click the like and subscribe buttons. I'll be back before long with some thoughts about trig, and here's a teaser. Set your calculator to degrees mode. Enter 30 and hit the sine function. Now, assuming your calculator is functioning correctly, it will say the sine of 30 degrees is 0.5. But is it really? Is it actually 0.5? Of course it is. But I need some clickbait. The sine of 30 degrees is 0.5, but that's also the distance in fathoms to my computer monitor. Context is everything. So 0.5 needs a setting before it's really the sine of 30 degrees. I'll do my best next time we meet. See you then.